Hey folks, welcome back. This is CSE1300, and today we are going to look at reading information in from your user and also using arithmetic operators. So today's going to be action-packed. All right, so first off, we need to talk about the different people that are involved in your coding exercises. So we use these terms quite frequently, and so I want you to be aware of what they are. So you, as a person who is writing the software, you are a programmer, you might be called a coder, you might be called a developer. All of those words are basically interchangeable. The coder, the developer, the programmer is the person who sits down, creates an algorithm, converts the algorithm into source code, types it into the IDE, compiles it, and eventually ships it. There's a separate person who might be involved in all of this, which is a user. This is somebody who uses the software that you have built. And it's important to distinguish the user from the programmer, because in today's class, we're going to be talking about how the user interacts with the program that the programmer writes. And so it's sometimes confusing as to who we mean by that user. So a user is a person who is using your software. It quite frequently will not be you. When you write code, you have to think about what is the user going to see? What is the user going to do? What is the user expected to do? What if the user does something wrong? And all of these are things that your algorithm needs to take care of, and you need to have code that deals with all of those circumstances. For example, if you're expecting the user to type something in, you're going to need to tell the user what it is you want them to type in. All right, so that brings us to reading from the user. So far we have seen system.out.println. And that's how you can send information to your user from the program. So system.out.println makes something appear on the screen, on the console as we call it, for the user to read. What we now want to do is we want to take something from the console that the user gave us and get it back into our program, and that's what reading means. You're reading information from your user, you're capturing it into some form of a variable, and then you're storing it. So, for example, if you wanted to ask the user for their name, then you would first probably use a system.out.println to tell the user that you're expecting them to type in their name. So please enter your name, or hi, what is your name? And then you would tell the program that you want to wait for it to allow them to type in an answer. All right. So the code for this is going to be a little bit weird, and I'm going to gloss over some of the details because they're not important. Basically, what I'm going to tell you is that there are 2 lines you pretty much need to memorize, and then the third line I'll explain in a little bit more detail. So in Java, in order to read information in from the user, you're going to use something called a scanner object. In order to use a scanner object, you're going to first need to read in the library that the scanner uses, which is going to be done with that import statement right there. Well, this was a terrible way to do that. Let me use a finger. There we go. So import Java util scanner is going to need to happen at the very top of your code. Once you have done that, the next thing you're going to do is you're going to do this big long line, which is pretty much always going to be the same. So the line that I circled in green is scanner followed by a variable name. In my case, I called it myscan, but you can call it scan, scanner. Well, you can't call it scanner with a capital S, but because that's a keyword. But you can call it anything you want. So myscan is a common name. Equals new scanner, and then in parentheses, you're putting in system.in. Now, you might ask, well, what does all of that mean, and what is an object, and why am I doing all of this? We're going to deal with objects much later on. Actually, in this class, we're going to give you a brief introduction to them. In 1321, if you move on there, you're going to spend a couple of weeks talking about objects. But the short version is, an object is a way to take something from the external world and write it in code so that it mimics something from the external world. Now the question is, what does a scanner mimic from the external world? And that's a good question. We're just going to go with it. All right, so pretty much the 2 lines that I have circled there in red and in green are lines that you are going to need to memorize. I will tell you there are a couple of things here that are tricky to remember. That is always going to be a capital S in scanner there. And as a matter of fact, for that matter, the S in scanner is always capitalized as well. So you have to capitalize all of those letters, otherwise it won't work. And at the end of all of that, you're going to have a variable, and that variable is called myscan. Now you might say, okay, we've talked about variables in the last one, and we talked about making a float or a bool or a double or a car or any of the other basic types or even a string. So what type is myscan? Well, the answer is it's a scanner, which is another data type that we haven't really talked about because it's an object. And again, not really in the scope of this class. You're just going to need to memorize those 2 lines. All right, so once you've memorized the 2 lines that I have up there in parentheses, then you're able to, as often as you want, read in 1 line from the user. And that's done with the line that I just underlined, myscan.nextLine. So what that does is it's going to pull 1 line of text from your user. All right, so let's take a look at how all of this fits together. Well, okay, there we go. Okay, so we start off with a piece of code, and this is a full program that asks the user for their name and then reads in their name and says hello back to them. All right, so we start off at the top and we have our import statement. So we import Java util scanner, and then we have our normal skeleton, which is this line, this line, this line, and this line. So those are all just part of the skeleton. And then I told you you're always going to need that scanner, myscan equals new scanner system.in. That's the other line I told you to memorize. All right, so once you put all of those in, then really the code is the 3 lines that I just put a blue line next to. So I have a print statement that asks them for a name, and then I say string username equals myscan.nextLine. All right, so let's break this down into its bits. So first off, I'm declaring a string, and I'm calling it user's name. So that's no different than we've done before. I'm declaring a variable. It's called user's name, and it is of type string. And then what I'm assigning to it is I'm asking it to use myscan, which is this variable up here, .nextLine, because I wanted to pull in 1 line from the user. So at the end of that statement, I have a variable called user's name, which will have a name in it. So then on the next statement, I'm able to say hello and user's name. All right, so I'm going to stick this into a replet real quick, and we're going to take a look at how that works. All right, so we import. Oops, why is that not working? All right, Java util scanner, and then we're going to add in our scanner, myscan equals new scanner, and then it's system.in. All right, and then we said system.out.println, enter your name, and then I read in a line, which I stored in a string, username equals myscan.nextLine, and then I said hello, and I did plus username. Oops, that's supposed to be in the parentheses. All right, so when we run this, what's going to happen is the computer is going to compile it first, as always, make sure that I didn't have any syntax errors, and then it is going to print onto the screen, enter your name. And then it's going to sit there and it's going to wait forevermore until I actually type in a name. So the program is running. If you notice up here, it's not sitting there with the run button, it's sitting there with the stop button. So it's waiting for me to do something. It's specifically waiting for me to enter my name. So I'm going to type in Enda, and I'm going to hit enter, and you see it says hello Enda. So this was the line that was waiting forever and ever. It was waiting for me to type in something, and then once I typed it in and hit enter, it knew that I was done, so it stored what I typed in into username, and it gave me back hello Enda. So hopefully that makes sense with regard to reading in information and storing it into a variable. All right. And here we have a run of that just so that you can see what it looks like. All right, so you will always use this anytime that you're doing a myscan.nextLine, you're going to need to put that into some form of a variable. And nextLine specifically always returns a string. So you're always going to want the variable to be of type string. Now, it is possible to break those 2 parts up into 2 separate lines. So, for example, I could say string username, semicolon, that declares a variable called username, which is of type string. And then on the next line, I could say username equals myscan.nextLine. But the important part is the fact that at some point, you are taking the answer from next line and you're storing it into a variable. Otherwise, what's the point? If you didn't store it in a variable, what they type in is just lost. And let me explain what I mean by that. So, okay, there we go. My shortcuts are not working. Okay, there we go. So what I'm going to do is I'm just going to take out this string username here, and I'm just going to call myscan.nextLine. And I'm going to, well, okay, I tell you what, I will make a string username, but I will set it equal to Bob. Okay, so I created a username variable, I set it equal to Bob, and then I did my next line, and then I print out the username. So the program will seem to work the same way. It's going to compile it, it's going to ask me to enter a name, I'm going to type in Enda, like I did before, but it says hello Bob. It doesn't say hello Enda. And why is that? Well, the Enda that I typed in there, which was typed into that line, it didn't go anywhere. I didn't store it in any kind of a variable, so therefore in the program, username was never changed. If I change this to username equals myscan.nextLine, then all of a sudden it'll work fine. So my username was originally Bob, I read in a new answer, I store it in username, and when I print out hello, I get hello Enda. All right, so it's very important that you actually store the value that you get back from nextLine into a variable, otherwise, what's the point? So make sure that you always do that. All right, so what happens if you want to read in something other than a string? So in this case, I was reading in Enda, which is a string, but sometimes you might need a number, or a double, or a float, or a boolean, or a character. So how would you do all of that? Well, similar to next line, there is a bunch of other methods that allow you to do other things. So we have myscan.nextInt, which will read in one integer, myscan.nextDouble, which will read in a double, myscan.nextFloat, next boolean. Next is kind of a weird one, I'll come back to that, and this one's the weirdest of all of them. If you want to read in one character, then you're going to do myscan.next parentheses .char at 0. Okay, don't worry about that last one too much. It is important that you understand that it reads in a character, and again, it's probably something you just need to memorize for right now. In later classes, we'll explain what's going on in this latter part of it, but effectively, Java doesn't have a method for reading in a character, so what it does is it allows you to read in a token, and then pull out the first character out of that token, which is what's happening there. And again, the details of that are not important, but you should be aware of all of those, because sometimes you will need one or more of them. So if you're trying to read in something that is not a number, then you're going to need, that is not a string, then you're going to need next int or next char or next bool or anything like that. All right, so anytime that you're expecting the user to type something in, you're going to want to tell the user what it is that you're expecting. So for example, if you're expecting the user to type in a number, you'd probably want to tell them, please type in a number between 1 and 100, or please type in a number between 1 and 7, or rate on a scale of 1 to 5 what you think of this class, or whatever it is you are expecting the user to do, you need to tell them that so that they understand what it is that they're supposed to do. And then you would read in the number. All right, so why is this being so weird on me today? There we go. All right, let's do an example with that over in the Replit window. So what I'm going to do is I'm going to ask the user to enter in a number. And we're going to start off, and we are going to, I'm going to create a new Replit in the hopes that this fixes my craziness that's happening at the moment. And also so that you guys can go back to the previous one if you wanted to. Again, you can always grab the URL that's up here, and if you type that into your browser, you'll be able to see the exact code, and you'll actually be able to fork it, which gives you a copy of it in Replit, and then you can play with it as well. That's part of the reason that I do this in here. So you can pause the video and grab the URL from up here. They are a bit weird. These are just made up words. It picks 3 random words each time I make a new Replit. All right. Hey, my shortcuts work. Great. So now what I'm going to do is I'm going to... the same thing as before, I'm going to, well, they worked for a glorious second. Okay. Import Java util scanner, and then I'm going to do that same weird scanner, myscan, and just to prove a point, I'm going to call it something else this time. The scanner. This is just a variable name. That's the only part of this that you can change. All the rest of it has to stay the same. All right, and so now what I'm going to do is I'm going to tell the user that I would like them to enter a number between 1 and 10. All right, and now I'm going to read in that number. So we're going to say there we go. We're going to say int user's number. And again, I can call that whatever I want. I just made a variable name. I called it user number. And I'm going to do the scanner dot next int, because that's how I read in a number. And then I'm just going to print it back out again. So system.out.println, you gave me plus user number. The variable name is user number. All right, so if we run that. So the thing that's different here is I didn't do next line, I did next int. Next int is going to read in an integer. So as a result, the variable that I'm storing it in must be an integer number, otherwise it's not going to work. So I'm going to type in 6, and it says you gave me 6. Now, to be fair, the computer has no understanding that it's supposed to be a number between 1 and 10. So even if I type in 100 right now, it still says, okay, you gave me 100. It really has no understanding as to what's going on because I haven't told it how to do any of that yet. We'll get to that later this week. All right, so that successfully reads in a number, and you can certainly use all of the other methods in here that we showed you. So you have next int to get in an integer, next double and float, which will give you doubles and floats respectively, next boolean, and then I never really mentioned what's going on with next. If you just do next, it gives you a token, which is a weird thing to say. A token is defined as a word, so basically reads in a word, but the definition of that's a little bit weird, because 1, 2, 3, 4 space 5, 6, 7, 8 would give you 1, 2, 3, 4, because the first part of that is considered a word. So it's basically everything up to a space is pretty much what a next will return. You won't use that one very often. Most of the time you're going to use next int or next line, which was the one we saw previously to get in a string. So there you go. All right. So that ends reading information in from the user. So now we're going to move on to the next section, which is arithmetic operators, which is how you do math inside of Java. All right, so we're going to start off with a very basic program. So we have the usual skeleton, class main, public static void main. And then what I did was I declared a variable a, and I set it equal to 15 plus 5. And it says a is 20. When I run this program, I get output of a is 20. So that works pretty much exactly as you would expect it to. Let's go ahead and do that over here. And again, I'm just going to start another replit just so that you guys can go back to the previous one if you wanted to. All right. So with arithmetic operators, you can do all the normal things you would expect to be able to do. You can do plus, minus, multiply, divide. You can do modulus, which we're going to see here in a few moments, which is kind of cool as well. And you can do it with either variables or with literals. All right, so in that last example, what I wrote was int a equals 15 plus 5. And then I printed out a is, and we're going to do plus a, so it outputs the actual variable, and I'm going to run this, and you're going to see that I get a is 20, which is indeed what 15 plus 5 is. So no big surprises here. We just never mentioned it before, but you can do math. Yay. All right, a is 20. I will point out that the spacing here is irrelevant. If you prefer to have spaces that look like that, you are welcome to do that, and that'll still output a is 20. You could have even put spaces before here. You can put a space after that. All of that has no meaning to the computer. It's just going to do the same thing either way. So all of that produces the same answer. Generally, you're going to want it to be readable. So generally, you're going to want to put it such that it's, how you would have written it on a piece of paper, which is either like that or like that, just depending on how many spaces you tend to like. All right, so that gives us basic output. All right, now let's do it with a variable. All right, so this time I set a variable x, which is now equal to 7, and I created another variable y, which is equal to 9, and then I said z is equal to x plus y. All right, so let's do that one. So we have int x equals 7, I believe is what it was. Yes, it is. I'm just going to pull that down so I can do that. And then int y equals 9, and then int z is equal to x plus y. And then I'm going to print out, I tell you what, z is plus z, and a semicolon. All right, so the first one's still going to print A is 20 because nothing has changed there. A is 15 plus 5, so A is still 20. But the second print statement is going to print out Z is 16, and that's because it's taking the value of X and the value of Y, and it's adding them together and storing that in Z, and so I end up with Z is equal to 16. All right, so my point here is that you can use variables and even constants inside of arithmetic operators. All right, so let's talk about the basic arithmetic operators. So arithmetic operators are addition, subtraction, multiplication, division, and modulus. Addition and subtraction are pretty simple. I don't have to spend a huge amount of time talking about those. I think you immediately understand how addition and subtraction works. You can certainly have more than one thing. So I could say Z is equal to X plus Y plus A plus 7, and you can mix and match things as much as you want, and it will still work. And you can add in subtracts in there and all the rest, and that'll cause no problems. So you can have as many operators in there as you want in a single statement. So Z is now 43, and that seems to make sense because that used to be 16. 16 plus 20 is 36, plus 7 is indeed 43. All right, so addition and subtraction, pretty simple. Multiplication is also very simple. The only thing I would warn you about there is be careful because you can exceed the maximum size of an integer if you're doing big numbers. And so just remember that an integer can only hold up to 2.5 billion. So if you're multiplying two very large numbers, you probably want to store the result in a long. That's the only thing to remember there. But addition, subtraction, multiplication, real easy. Division and modulus are a little bit more tricky, so let's talk about them next. Okay, so first off, division. Generally, you would think that A equals 1 divided by 2, and that is how you would write that. It is a slash. You would expect that to print out 0.5 because, well, that is what 1 divided by 2 is. And so let's do it. All right, so we're going to create yet another replit here. And what we're going to do is we're going to say, I didn't choose a template. All right, there we go. Okay, so int A equals 1 divided by 2, and then we're going to print out A is, and then plus A. All right, now you would expect the answer to be 0.5. But instead, what we're going to get is 0. This is going to output 0. So let's talk about why this is happening. So I told it to take the number 1 and divide it by 2. And in your brain, that obviously is a half. But then I told it to assign that value to an integer. And remember that integers cannot have decimal points. So it can't store 0.5 in an integer. And the rule of converting to an integer is that it just takes everything after the decimal point and throws it away. Despite the fact that it was a 0.5 and it should have rounded up to 1, it doesn't do that. It just says, all right, 0. So the rules of converting to an integer is if there is a decimal point, you just chop it off and ignore everything that's after it. So 7.999999999 is still equal to 7. And that would be very bad for calculating your grade. If you got an 89.499999, well, you got an 89. Anyway, the better example would have been you got an 89.99 and you still get an 89 instead of getting an A. Anyway, so that's the first problem. You can't store that in an integer. So great. Your next solution is just make it a double. Double A is equal to a half, and now this should all work, right? So I'm going to change this int to a double, and I'm going to hit run. And you would expect the answer is going to be 0.5. It's not going to be 0.5. Spoiler alert. 0.0. Now, this is probably very confusing to you because it seems like you did all the right things. You told it was storing it into a double, which can absolutely hold decimal points. You asked it to divide 1 by 2, and obviously the answer is 0.5. Why on earth is it showing you 0.0? And the answer is because I mentioned when we talked about floating point operators at the very beginning that floating point is really expensive for the computer to do in terms of amount of work. So anytime it thinks it can avoid it, it's going to avoid it. And this is a circumstance where it thinks it can avoid it, but it really shouldn't avoid it. So what it did was it took 1 and divided by 2 and stored that as an integer, and then it tried to convert that result into a double. But by the time that it went to convert it, it had already lost the 0.5. So how do I fix this? Well, you're going to have to do something weird. You're going to have to change one side of it to look like a double. So the moment that I say 1.0 up here, and you might say, but that's exactly the same thing. Yes, it is. But the 0.0 makes it so that it can't pretend it's an integer. It has to do floating point now. And so as a result, I finally get the right answer. To be clear, it doesn't matter which side you do the 0.0 on. If you do it on either side, you will get the right answer. And furthermore, if you do it on both sides, you'll get the right answer. It's just that one of the two things has to be a floating point, and in that case, it has no choice but to do floating point. And again, I'm storing it as a double when I'm saying the word floating point. Double is an example of a floating point number. It's just the more precise version. So the correct answer is anytime you're dealing with floating point numbers, you need to force them into floating point numbers by either putting a .0 on there, or Java has another way of doing this. You can put an F at the end of either of the numbers, and that will force it to a floating point. So the F stands for floating point. And again, even though you're using it as a double, floating point is the type. They are all of doubles, and floats are both floating point numbers. All right, so all that's very confusing, and that's why I said with regard to division, it's a little bit more complicated than you would think. So here are the 3 examples that I wrote over on the right-hand side. You're going to always need to remember to convert the number into a floating point number before you're going to be able to do floating point math. And either you do that by putting an F on there, or you specifically hardcode a 0.0 onto the end of the numbers. All right, so that is division. What about modulus, which was the last of the types that I mentioned up here? So I said for basic math, you have plus, minus, star, divide, and now you have this modulus. So let's talk about modulus. In Java, and actually in every language, when you do division, often you're going to do it as integer division. Instead of dealing with the floating point stuff, it's common that you just deal with it as an integer. And there's reasons for doing that, which I'm not going to go into. But it's not an uncommon thing to not care about the remainder when you're doing the division. So if you need the remainder later on, that's where you get the modulus. So division and modulus are related. Division gives you the actual answer from a division. Modulus gives you the remainder that was left over from the division. So let's take an example. So effectively what it's asking is, if I say 10 divided by 4, you know that the answer is 2. And again, we're only talking in integers here. So let's not worry about the floating point thing we just talked about. How many times does 4 go into 10? The answer is 2. But there's something more to that, right? Because it went in twice, but 2 fours is only 8. It's not 10. So there are 2 left over, we would say. And that's what modulus gives us. If I do 10 mod 4, it responds with 2 because there's 2 left over. It's not giving me 2 because 4 goes into 10 2 times. It's giving me 2 because there's 2 left over. It doesn't care about how many times the denominator went into the numerator. All right, so let's go over this again. 13 divided by 7 in integer terms is 1. 7 goes into 13 one time. You can't go in twice because that will be 14. So 7 goes in one time. If I do 13 mod 7, I get the answer 6. Because after 7 goes into 13 once, there is 6 left over. 6 plus 7 gives you 13. So what mod is telling you is how much is left over after you do the division. So let's do some practice. All right, so 20 mod 4. So the question is, how many times does 4 go into 20? The answer is 5. But we don't care about that because that's not what was being asked. What was being asked was, what is the leftover? How many do we have left over after we do 4 into 20? And the answer to that question is nothing, because 4 goes into 20 evenly. So let's take a look at this. All right, so we have 20. And what we're going to do is we're going to mod it by 4. So effectively what's happening is, how many times can you subtract 4 from 20? That's really what division is telling you, right? If I say 10 divided by 2, I'm really asking how many times can I subtract 2 from 10? And the answer is 5. I can do it 5 times successfully. All right, so if we subtract 4 from 20, we get 16. If we subtract 4 from that, we get 12. If we subtract 4 from that, we get 8. If we subtract 4 from that, we get 4. And if we subtract 4 from that, we get 0. That 0 is the remainder. All right, so let's do it again with a different one. So we have 32 mod 3. All right, so subtract 3 from 32, and you're going to get 29. Subtract 3, and you're going to get 26. We're going to be here for a moment. 23. All right, I'm just going to do the other math here. So 23 minus 3 is going to be 20. 20 minus 3 is going to be 17. 17 minus 3 is going to be 14. 14 minus 3 is going to be 11. 11 minus 3 is going to be 8. 8 minus 3 is going to be 5. 5 minus 3 is going to be 2. And I can't subtract 3 again because I can't subtract 3 from 2. I would be in a negative number. So my remainder is 2. The division would have been how many times I did this? 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like the answer for the division was 10, because 10 times I could subtract 3 from 32, and that makes sense because 32 divided by 3 would be 10 point something, and there was 2 left over at the end of it. So that's how you calculate a modulus. All right, you should probably pause the video at this point and do the next one by yourself. So the next one is 5 mod 5. Okay, so presuming you're back, you subtract 5 from 5, and you get 0. So the answer to 5 mod 5 is going to be 0. All right, let's do the next one again. Pause the video. All right, so 100 mod 20, you're going to subtract 20. That gives you 80. Subtract 20, that gives you 60. Subtract 20, that gives you 40. Subtract 20, that gives you 20. Subtract 20, and that gives you 0. So 20 goes into 100 evenly, therefore the remainder is 0. So anytime something goes in evenly, you know that the remainder is going to be 0. So without doing all the math, I think you can probably guess what the answer to this one is, because you know from this one that it goes in evenly to 100, but it doesn't go in evenly to 101. So the answer to this one is going to be 1. And you can go check that yourself, because the 20s will subtract out, and at the very end you'll be left with 1. And likewise, if I said 102 mod 20, you'd get 2, because the 2 is left over at the end, and so on and so forth. So this is what modulus does. So it basically gives you the output from the remainder after a division. All right. And there's your answers to all of those. Okay. So I mentioned earlier, and I'll just say this again, you have to be careful when you're doing multiplication, because if you multiply 2 large numbers and you don't store it in something that can hold a large number, you're going to end up with an error. So if you type this in, int a equals 1,000,000 times 5,000, we know that the answer is going to be 5 billion, and we know that that's bigger than you can store inside of an int. So let's see, int a equals 1,000,000 times 5,000, and I'm going to not make that a, I'm going to make that b, because I already have an a. All right, so you would expect the answer to be 5 billion for b. B is 5 billion. You'd also expect that I would put a semicolon there. But you're not going to get 5 billion, you're going to get some completely weird number. And the reason is because 5 billion is too big to store in an integer, so it overflowed the integer is the technical term, and you end up with something completely weird like, it looks like 70 million, give or take. 705 million? Yeah, I think that's 705 million. No, it's 70 million. No, it is 705 million. Okay, I cannot read numbers today. That is 705 million, which is clearly not the correct answer, especially because, well, there's nothing past. It's all zeros. It should be 5,000,000,000,000, and I got 705,032,704. Not exactly the right answer. Okay, so if you put this into a long, all of a sudden that problem will go away, and you'll actually get your 5 billion answer, which is what you should have gotten in the first place. So just be careful when you're doing large multiplications that you store the result in a long number. All right, so I chuckled because I have the exact same problem that I have with floats there. It tries to do it as integers until I force it into a long, and much like you can put an F at the end of a letter to make it a floating point number, you can put an L at the end of a number to make it into a long. And once I do that, I suddenly get long. So be careful of all of that. All right, and that's explained in here where you have to put that L in there as well. All right, so that brings us to the last topic for today, which is order of precedent. And this is something that you covered in math, but we're going to go through it again because it is important. So the order of precedent is how you evaluate something that has a bunch of different math operators in it. So let's take the example here of 15 times 3 plus 4 divided by 2. So there's a lot happening in that statement. And if you remember, the way that this works according to math is multiply and divide have a higher order of precedent than plus and minus. So what happens here is this bit is going to be evaluated first, and that's going to give you 45. Then the divide is going to happen second, and that's going to give you 2. Then you're going to do the plus, which is going to give you 47. And the reason this is important is because if you do it in a different way, like if you just read it left to right, this is not correct. 15 times 3 is 45, plus 4 is 49, divide by 2 is going to give you 24, which is not the correct answer. So it is very important that you follow the rules of order of precedent. In general, and always, you will go from left to right. But you will do the leftmost thing of highest precedent, then you'll go towards the right for the other things of highest precedent, and then finally work your way back to the lower precedent, which is the plus. So that's the general rules of order of precedent. Now, there is some things that can change those rules, which are parentheses. So if I put a set of parentheses around this, all of a sudden this works completely differently. The parentheses will always have the highest order of precedent. So 3 plus 4 is going to be 7. So now we're left with 15 times 7 divided by 2. And that's going to be done with the 15 times 7 first, which is 105, and then the divide by 2, which is going to give you 52 as an integer. Because again, 2 goes into 105, 52, with some change left over, but we don't care about the change because it's all integers. All right, so that brings us to unary operators. A unary operator is a negative sign, and that happens before the parentheses. So if you have negative 3 times 4, you don't treat this as 3 times 4 and then put a negative on front of it, although that would actually work in this exact example. You do negative 3 times 4, which is going to be negative 12. And that's because the unary operators go first. All right, and then that brings us to assignment, because we've talked about assignments here in our Java code, where we would say x is equal to some number. Well, that assignment actually has the lowest of the priorities. That's going to happen last. Okay, so let's take a look at this particular statement and let's see how this is going to work. So we have all kinds of things happening here. We have inner parentheses, we have outer parentheses, we have multiplies, we have adds, we have subtracts, we have divides, and then we have an assignment. So the way this is going to get evaluated is the innermost parentheses are going to happen first. So that's 2 minus 1, which is going to give you 1. All right, and then effectively we're going to cross that out because we've dealt with that. It's now 1. The outer parentheses, which are this bit, are now going to happen. 1 times 3 is going to be 3, and so we're going to cross out all of this because we now have 3 there. All right. Next off, we're going to start at the left side and we're going to do the multiply. So 15 times 3 is, we learned, 45, plus what's left of these parentheses is effectively a 3 divided by 4.0. All right. So 3 divided by 4.0 is 3/4. And since this is all being stored in a double, and since that is a double, it's going to do this as floating point. So 3 divided by 4 is going to be 0.75. And then 45 plus 0.75 is equal to 45.75. So that's the answer to all of this, the math part. The last step is that is going to get assigned into our x variable. So x is now going to be equal to 45.75. And so that's what this next slide shows. It's just the breakdown of all of those steps. You do the multiplication and the division left to right. You do the pluses and minuses left to right. The parentheses, you go from the innermost parenthesis and you work your way out, and the assignment is the last thing that we deal with there. All right? So let's talk about this one. X is equal to 7. I'm just going to type this one into the computer over here. All right, so int x is equal to 7. And then we have x equals x plus 1. And then we have a system.out.println x is plus x. Okay, so the question is, how does this statement work? So we know that x is equal to 7 on line 3. That's nothing crazy going on there. But on line 5 here, we have an x equals x plus 1. And there's two ways you could read this. One of them is correct. So let's start with the wrong way. You could say x is equal to x plus 1, meaning x is equal to 7, and then plus 1 somehow makes 8. But that's not what happens. The assignment happens last. So ignore everything that I just highlighted in blue. And instead, we're going to focus on the part that's not highlighted. So x plus 1, the current value of x is 7. We're going to add 1 to that, which brings us to 8. Then we're going to do the assignment, which means that the x is now equal to 8. So when I run this code, what I get is x is 8. And that's because it took the 7, it added 1 to it, and then it assigned that result into the x. If I were to do this again, x would now be 9, because on this line, the 7 would become 8, and x would be changed to 8. When we get to this line, 8 plus 1 is 9, and that gets assigned to x, so x is now equal to 9. So every time that you do this, x is going to increase in value by 1, or we might use the word it's going to increment by 1. And the reason we use this word increment is because this happens very often, where you need something that just gets bigger by 1 as the program is going. Seconds work like this, right? Pretty much up until you get to 60. So seconds, 0 minutes after an hour, and then 0 seconds after a minute, then it's 1, 2, 3, 4, 5, 6, all the way up until you get to 7, or until you get to 59. Once you get to 59, it goes back to 0, which is a little weird, but the seconds effectively count by adding 1 to them continuously throughout the day. So this happens very often, and as a result, there's a shortcut in the language for doing this. So this line of code is actually equal to this line of code. They mean exactly the same thing. So if all you're trying to do is add 1 to a number, you can simply say x plus plus. This is a special operator that exists in Java that allows you to do an increment. So I'm going to leave those there, and I'm just going to say x plus plus down here. And what do we think the value of 9 is now? Spoiler alert, it's going to be 11. And that's because it started as 7. We added 1 to it in this line, which made it 8. We added 1 to it in this line, which made it 9. These lines are the same. We added 1 to it, which is 10, and we added 1, which is 11. So this is called the increment. There is also a decrement, because if you had wanted to say x equals x minus 1, which is something else that happens fairly often, the shortcut for that is x minus minus. And so at this point, I have started with 7, I added 1, I added 1, I added 1, I added 1, I subtracted 1, I subtracted 1, I subtracted 1, I subtracted 1, I believe x is going to be back to being 7 again. And it is. All right, so two shortcuts to be aware of there. We have x equal x plus plus. I'm sorry, x equals x plus 1 is abbreviated to x plus plus. And here is the list of all of the shortcuts that you can have. So the first one is x equals x plus 1. And as we said, that is the, sorry, I'm trying to clear the screen. There it is. All right, that is the x plus plus operator. All right. X equals x minus 1, I just showed you, is x minus minus. And there are other ones that you can use. If you want to move it by more than 1, so if you were trying to do x equals x plus 3, that becomes x plus equals 3. That means take the value of x and add 3 to it instead of adding 1 to it, which is what x plus plus did. X equals x minus 4 gives you x minus equals 4. And then x star equals 2 gives you, sorry, I'm just going to bring this up full screen so that they're a little more easy to read. All right, so x equals x plus 1, x plus plus. X equals x minus 1, x minus minus. X equals x plus 3, x plus equals 3. X minus equals 4 is how you would subtract 4 from a number. Times equal 2 will multiply the number by 2. Divide equals 2, we'll divide it by 2, and mod equals 2 will take the modulus of it by 2. That one's not very common, but you will occasionally see it. Certainly this and this are very common, and this are pretty common. So one footnote is you can't put a space in between the minus and the equals or the star and the equals. They have to be plus equals, star equals, all in one with no spaces in between. All right, so let's play with some of these in code real quick. So over in my Replit window here, what I'm going to do is I'm going to start off and we have x equals 7, and we're just going to try a couple of things with that. So what I'm going to do is x plus plus, then I'm going to do x plus equals 4, and then I'm going to do x divide equals 3. All right, so I want you to pause for just a moment and think about what the final answer is going to be here. All right, so we started with x equals 7. I added 1 to it, which made it 8. I then added 4 to it, which would bring it to 12. I divided it by 3, which would bring it back to 4. All right, so each one of those is equivalent, and I'll just write their equivalencies in there. X equals x plus 4. The equivalent of this one would be x equals x divided by 3. And the equivalent of this one is x equals x plus 1. All right, so hopefully that makes sense. So these are shortcuts. You're going to see them all the time because, well, it's nice to be able to type it with less things. So our last example here is going to be write a program that reads in 2 numbers from the user, multiplies the 2 numbers together, and prints out the result. All right, so a very basic calculator. And again, I'll just start off a new Replit window here real quick. All right, and so we are supposed to read in 2 numbers from the user, and then we are supposed to multiply them together. So we're going to ask the user, enter number 1. All right, now if we're going to read in a number, we're going to need that scanner. So we need the 2 lines that we memorized, import Java util scanner. And then down here, we need to make the scanner object, scanner myscan equals new scanner system.in. All right, so now that we have the ability to read in, what are we reading in? We're supposed to be reading in a number. So I'm going to call it int number 1 is equal to myscan.nextInt. All right, I'm going to tell the user that I'm expecting number 2, system.out.println, enter number 2, and then int num2. I need to store this in a different variable because otherwise I would mix the 2 of them up. myscan.nextInt. All right, and now I'm supposed to multiply the 2 of those together. So I'm going to say int answer is num1 times num2, and then I'm supposed to print out the answer. System.out.println, answer is plus answer. All right, so if we run this guy, it's going to ask me to enter in a number. I'm going to type in 10. It's going to ask me to enter in another number. I'm going to type in 5, and then it's going to tell me that the answer is 50 because 10 times 5 is 50. So 10, 5, and you see it says answer is 50. And I can do that for any set of numbers because the user is allowed to enter stuff in. And that's the important part of reading information in from the user. So now I've written a program that it's not always going to give the same answer. Depending on what the user types in, 80 times 5, well, the answer is 400. I get a different answer every time depending on what the user types in because the code is specifically reading in information from the user and then using it to do math. And so I think you can start to see how your calculator works on your phone or on your computer. It's basically just got a bunch of buttons that allow you to type in a number, and then it's doing this in the background. All right, and so the answer to that is also here in the slides. All these slides are posted in the D2L shell, and they're also on the FYE site. So that completes today's lesson, and I will see you guys in the next one.